Good morning, everyone. My name is Jay Harikrishna. I am working as assistant professor in Annamacharya University, Rajampet, in Department of Computer Applications. I am giving a demo in operating system. One of the topic is deadlocks. Before going to discuss about the deadlocks, we are need to discuss the topic as system models. However, present how the system will be working, that it will be defined the deadlock will occur or not. So the system models, it's consisting a finite number of resources to distribute among a number of computing processes. The resources are partitioned into several types, each consisting of some number of identical instances like memory space, CPU, files, and the input-output devices. For example, if a system consisting and having two CPUs, the resource type is 2. If one more example, the system consists of having two printers, it will be defining the resource type of printer is 2. And it's like how it will be working means, so the system will be requesting the resource, then it will be using, and then it will be released. Based on these three concepts, the system will be working. The system model defining the process of working of a mechanism inside of the operating system. So here we are having how the request will be comes, and how the use will be comes, and how the release will be comes. So the first one is request. Now, for example, if you are working with the printer or scanner, so first you will be need to give a request through the input device. Then the printer will be having freely, it will be allocating to take printer. If the system requested the printer is not available, then it will be need to wait some time. So same the thing. So request if it is granted, then it will be allocating to the user or system. At that time only we can take the printer. And here the request, it will be granting or permitting time based on the other resources utilization. And the next comes to the use. The use option, how it will be using based on the process. If you are only taking a printout through the printer based on your requirements, if you are taking 20 pages of print, it will be taking to use more time. If that one only, if you are need to take 1 or 2 printouts, it will be taking that less time. So based on that, how much time the user or the system will be utilizing, that we can call here using of the process. And next, last one, release. Once the process or printing is completed, then automatically the system will be releasing the resource of a print. So based on these three concepts, the system model will be work. So if like this working time, there will be no problem. But when one user or one system is depending on the another system or another process, it will be waiting, then it gets deadlock. So deadlock means a process which is requested by the other system. If it will be unknown, then the there will be a no problem. So if the system is not allocated, that whatever we are waiting for the resource or for the process, that we are saying here deadlock means a waiting time of a resource, we can call here deadlock. So here the deadlocks will be having based on two methods, that is necessary conditions and another one is resource allocation graphs. So these two methods mainly it will be creating the deadlock. So deadlock when occurs means when the resource is waiting for the, so when a process is waiting for the a resource, that waiting time we are calling here deadlock. And comes to the necessary conditions. So mainly these four conditions, it will be defining the system will be comes under the deadlock condition or not. So here the first part is mutual exclusion. Second one is hold and wait. Third one is no preemption. And fourth one is circular wait. No preemption and mutual exclusion. These are one type of mechanism, and hold and wait and circular wait is it will be defining another type of mechanism. So comes to the first one, mutual exclusion. It will be defining at least one resource must be held in a non-shareable mode. That is only one process at a time can use the resource. How it will be means if you are using one printer through your system, so the other member, whatever it's connected to the other systems for a printer, means a printer can connect, we can connect more than 3 to 5 systems. So now I'm taking one system onwards a print. So the other systems will be waiting like that if it will be holding a one resource and waiting for the other resources. Means it will be holding a non-shareable mode. So here the printer we are shared, but whatever the using person that is, we can define as a non-shareable mode. If like that working means the deadlock will comes. And the next, hold and wait. A process must be holding at least one resource and waiting to acquire additional resources that are currently being held by the other processes. Means now I want to use a scanner, but I'm holding a printer. So means I need both resources at a time. At that point of view, I am utilizing printer means holding the printer and requesting for the scanner. At the same time, the other person or other system member, it will be the same process. Means he will be hold the scanner and waiting for the printer. At that time, this problem will comes. And next, third one, no preemption. So resources cannot be preempted. That is, a resource can be released only voluntarily by the process holding it. Means if I am need to or I am waiting for other resources at that time, whatever I am hold printer or other resources, if I am released, the other members will be completing their work. Means by myself or by the system self, it will be need to release the, it means voluntarily need to release the resources. Then only it will be completing the process. Otherwise, it will be also creating a deadlock mechanism. And next, last one, circular weight. So the same point of the things, the circular weight also, it will be working like a circle, and means the all systems will be created in a circle, and means a process of utilization by the system, it will be depending on the other system resource like that, and means first system will be waiting for one resource, and the second system will be depending on the first system resources, and the third system will be depending on the second system resources, and the fourth system will be depending on the third system resources like that, and fourth system will be depending on the first system resources. So like that, a circle, if it will be formed, then we can call that circular weight. So based on this four characterization of necessary conditions, the deadlock system may occur. If any one of these methods, if we are means avoided, that it will be not comes under the deadlock condition. Next, we are discussing about second point, resource allocation graphs. The resource allocation graph means we are defining the system through the diagrams. Through this diagram, the resources will be and the processes will be, how it will be allocated and how it will be releasing for a process. So here we are defining 2 points. One is request edge and another one is assignment edge. Request edge will requesting from a process for the resource. Assignment edge means a resource is already allocated to the process. So based on these 2 conditions, the resource allocation graph will be worked. And means it's here not having any conditions. We are just showing through a diagram how it will be requesting and how it will be assigned the process of resources. So from this diagram, the process P1. So here we are having 3 processes and 4 resources. And R1 containing only 1 resource, R2 containing 2 resources, R3 containing 1 resource, and R4 containing 3 resources. Resources means simply to here only 1 printer, here having 2 scanners, and here having 3 CPUs, and here that we have only sharing of 1 output of process. So the process 1 means these 3 programs, if need to complete their execution, the process 1 need R1 resource, but R1 is resource is allocated to the P2 process. Now, P2 process need R3 resource, but R3 resource is allocated for the P3 process. At the same time, P1 is already have or hold the R2 resource. P2 also holding the R2 resource. Now, this here, if formed any cycle, means if this program is not release a resource up to that time, this program will be waiting for this resource. If P2 is released this resource, then completing the P1 process and releasing the remaining two resources. So like that, each and every process will be requesting some resources and assigned by the other resources. For example, if we see this is a cycle, so P1 is requesting R1, but R1 is assigned to the P2 process. Now, the P2 process will be completed their execution. Then the P2 program or process will be releasing the R1 resource. At that time only, the P1 resource will be completing their execution. Like that, the resource allocation graph and the necessary conditions will be work. So again, defining the things, what we are discussing today as our demo. First one is how the system will be work. Based on the system model, it will be first requesting the resources and then it will be using and then it will be released. Based on that condition, the system will be work. But when it will comes a deadlock mechanism means when a program or process is request for a resource that if allocated immediately, that will be not creating a problem. If that will be waiting time is too long, then we can call that deadlock. So here a resource is allocated immediately, that will be not give any problem. When it will be waiting too much time or too long time for a resource, then the deadlock will comes up. So, and how the deadlock will comes to the to the face means hit based on two characterizations. One is necessary conditions and another one is resource allocation graph. The necessary condition will be defined 4 points: mutual exclusion, golden weight, no preemption, and circular. So these 4 conditions, if it's satisfied, then the deadlock will not come occur. If any one problem is raised, the deadlock will comes. And the second one, resource allocation graph. The resource allocation graph we are showing through the diagram, and here we are defining 2 points: request edge, assignment edge. Process will be requesting a resource. If we are indicated arrow mark like this, that we can call request edge. The arrow mark will be indicated like this from resource to process, that we can call assignment. So that's it today for the demo lesson. Thank you. Have a good day.